Guys. Hey guys. All right. I'm going to make a video while talk you through a PowerPoint since the weather's, supposed to be kind of iffy tomorrow. Classes have been kind of called off. So our class won't meet on Thursday, tomorrow. So you're going to watch this video instead, similarly to when you watched the video last week. So just like last time, I need you to take notes while you're watching the video. You can stop and rewind. Make sure you write down the rule. Make sure you write down the examples. If something's confusing you, feel free to email me or make a note and you can ask me in class next week. Hopefully just stay safe, okay? So I'm going to share this PowerPoint with you, all right? So let's see what we've got. All right, so we're going to share this one. All right, so it's called combinations of functions. So what's going to happen is, you've been having one function like f of x, and then it would say find f of 2. So you would take 2 and substitute in your f function and get your answer back out. Okay, then they would change and have a different function like g, and it would say g at 1. So you take 1 and plug it in for x in your g and get your answer back out. All right, now what's going to happen is in the same problem, they're going to have more than one function. And they're going to take those two different functions, they're going to put them together different ways. So we're going to talk about you can add functions, subtract functions, multiply functions, divide functions, and do composition of functions. So there's going to be 5 different things you have to be able to do by the time you finish watching the video. So like I said, copy down the notes, write down the examples, just like you're in class. And if you have any trouble, just email me. All right, let me show you what I'm talking about. A sum. The way the problems are going to look, it's going to say like f plus g in a parenthesis at x, and that's red, f plus g at x. So how do you find f plus g at x? Well, you do f of x first, and you add it to g of x. All right, so here's what we say on this first example. So if f of x was 3x plus 5, and then g of x was x squared minus x plus 4. Now, if it just said f at 1, you would just plug 1 into f and be finished. Or if it said, what's g at 3? You would just plug 3 into g and get the answer and you'd be finished. But what they're going to do right now is a couple of things. Sometimes they're just going to say find f plus g of x. Well, you have to know this rule. How do you find f plus g of x? Well, you just do f of x plus g of x. So look at my example. What is f of x? Well, f of x is 3x plus 5. So in place of f of x, I put 3x plus 5. And make sure you put them in a parenthesis. Plus, there's my plus, and then g of x. Well, g of x is x squared minus x plus 4. So I put x squared minus x plus 4 in parenthesis in place of g of x. So this is my f of x plus, and this is my g of x. And now I'm going to take care of the parentheses. Well, this first parenthesis isn't really doing me any good, so it's just dropped. But make sure on the second parenthesis, if you distribute that plus, it stays plus x squared, and then minus x, and then plus 4. Then you're going to group like terms. You've only got one squared term, x squared, but you've got a 3x minus 1x is where I got the 2x. And then I've got a 5 plus a 4, and I've got a 9. And I can't simplify that anymore. So when you add f of x to g of x, it turns into this cool new function. So you took an f of x and a g of x, 2 different functions, and you added them and you got a different function. Now, sometimes instead of saying f plus g of x, they'll say find f plus g at 3. Well, how do you do that? You do this first. So first you find f plus g of x. Then when you have this answer, then you plug in 3 for x. So remember, what was f plus g of x? I have to do all of this up here. And we got x squared plus 2x plus 9. So we did f plus g of x and figured out that f plus g of x was x squared plus 2x plus 9. So now I put 3 in for x. So that 3 goes in place of that x. That 3 goes in place of that x. Those 3 squared is 9. 2 times 3 is 6. So when I add all that up, I get 24. So if they tell you to do like f plus g at 5, you would first figure out what f plus g of x is. Then once you got that, you'd plug 5 in for x. If they wanted f plus g at -1, You'd figure out what f plus g of x is first, and then you'd plug in -1. Okay, so that's the way you add two functions together. Now, what if you were subtracting them? What if you were finding the difference? What if you had f minus g at x? Well, that's f of x minus g of x, the first one minus the second one. So the same example, if f of x is 3x plus 5 and g of x is x squared minus x plus 4, instead of adding them, we're going to subtract them. And the order matters. So first I use f of x. So I have 3x plus 5 in parentheses. And then minus, make sure I put a minus. And then I'm going to take away g of x. So make sure you put g of x in a parenthesis. Now, that first parenthesis isn't doing me any good, so it just gets dropped. But see, when I distribute this minus, it changes things. Minus x squared, and then minus a negative makes it a plus x, and then minus this 4. And then again, I group like terms. I've only got 1 squared, but it's a negative x squared. Then I've got a 3x plus an x is where I got the plus 4x. And then 5 minus 4 is a 1. So f minus g of x is a negative x squared plus 4x plus 1. I can't make that any simpler. Well, now, instead of asking me to find f minus g of x, what if they had said find g minus f of x? See, order matters when you're subtracting. So they listed g first, so I've got to do g first. See, up here they listed f first, so I got to do f first. So g minus f at x is g of x minus f of x. So now the g of x is first, minus, and the f of x, 3x plus 5, is second. Well, again, that first parenthesis isn't doing me any good, so it just gets dropped, but I got to distribute that minus, so it's minus 3x, and it's minus 5. So I've only got 1x squared, but I've got a minus x minus 3 more x's, I've got minus 4 x's. And then 4 minus 5 is a minus 1. And again, I can't simplify that any. But I want you to notice, this answer is not the same thing as this answer. So order doesn't matter when you're adding. Like 2 plus 3, same thing as 3 plus 2. That's called commutative property, when order doesn't matter. But when you're subtracting, order does matter. Order does not, differences, subtraction does not have the commutative property. You know, in your checking account, 20 minus 5 and 5 minus 20 are two completely different things. Okay? So be careful when you're subtracting because order matters. Now, what if they wanted f minus g at 4? Well, then I would figure out f minus g of x, and then I would plug a 4 in for x there and a 4 in for x there. If they wanted g minus f at 1, then I would find g minus f at x first, and then I'd plug a 1 in for x and a 1 in for x. So sometimes they'll leave it an x, and sometimes they'll put a number there. What if instead you're multiplying them? You know, when you have two variables with nothing between them, it's understood to be multiplication. So like xy means x times y. AB means a times b. So fg means f times g. So f times g at x is f of x times g of x. That's the product. It's what you get when you're multiplying them. So again, same example, same f of x, 3x plus 5, same g of x, x squared minus x plus 4. But this time I want you to multiply them. So I have to write the f of x down first times the g of x down second. What's f of x? Well, that's 3x plus 5. So I replace f of x with 3x plus 5. Well, what's g of x? X squared minus x plus 4. And now you're doing distributive property of multiplication over addition. Okay, so notice what you're doing. You got to do 3 of x times everything in this parenthesis. So 3 of x times x squared is 3x cubed. And then 3 of x times a minus x is a minus 3x squared. And then 3 of x times a 4 is a plus 12x. So when you multiply 3x times everything in that parenthesis, now you got to multiply 5 by everything in that parenthesis. So 5 times x squared is 5x squared. And then 5 times a minus x is a minus 5x. And then 5 times 4 is a 20. So just like foiling, okay, you take the first term and it must multiply by everything in the second parenthesis. Then you move to the second thing and multiply by everything in the second parenthesis. If you had a third thing, you would keep doing it. Then I'm going to group like terms. I've only got 1 cubed, 3x cubed. But now I've got a minus 3x squared and a plus 5x squared. When I combine them, that's where I got the plus 2x squared. And I've got a positive 12x minus a 5x, and 12x minus 5x is where I got 7x. And then I just got that plus 20. So, this is as simple as I can make it. None of these are alike. So what if they had told me to find f times g at 1? Well, I would have done all this first. I would have found f times g of x, just like I did here. And once I have that answer, then I plug 1 in for x. So 1 goes in for that x, and 1 goes in for that x, and 1 goes in for that x. Well, 1 cubed is 1. 1 squared is 1. 7 times 1 is 7. So 3 times 1 is 3, and 2 times 1 is 2. I still got a plus 7 and a plus 20. When I added all that up, I got 32. So sometimes they're going to ask you just to leave a letter there, and you'll get what looks like an algebraic equation. Sometimes, though, they'll have a number there, which means your answer will be a number, okay? But even if they put a number, you've got to find the one with the answer with the variable first, okay? So we've added them, we've subtracted them, we've multiplied them, now we're going to divide them. So what if they have a quotient? What if they have f divided by g at x? Well, that's f's on the top here, so f's got to be on the top there. G's on the bottom there, so g's got to be on the bottom there. So same f of x, same g of x. So what would f divided by g of x look like? Well, it'd be the top one divided by the bottom one. My top one is f. And remember, what was f? F was my 3x plus 5, so I replaced it. G of x is on the bottom, so I put my g of x on the bottom. And I can't simplify that anymore. All right? If I tried to factor it, nothing's going to divide out. So that's as simple as I can make it. Okay? Well, would you get the same answer if you put the g on top? And the answer is no. Division is not commutative. 1 divided by 4 is not the same thing as 4 divided by 1. Okay? So I've got to put the g on the top now. So now my g is on the top and my f is on the bottom. So see, these answers are not the same. Just like 3 over 4 and 4 over 3 aren't the same fraction, okay? So what if you had like f divided by g at 6? Well, without them telling you, you would first have to do f divided by g at x, like this, and get this answer. Now, what am I going to do with this answer? I'm going to plug 6 in for x here, here, and here. And that's what I did. See, I plugged 6 in for x, 6 in for x, and 6 in for x. Well, 3 times 6 is 18. And then 6 squared is 36. So 18 plus 5 is where I got the 23. And 36 minus 6 plus 4 is 34. And that fraction won't reduce. Well, what if instead you had g divided by f of 6? Well, now remember, I've got to find g divided by f of x first. And that was this. So now I plug in the 6. So when I do that, see, I don't get the same answer. You change the order, you're going to change the answer. So you should be able to add them, subtract them, multiply them, and divide them. Okay? Now, this one's a little different. This is called composition of functions. Now, that's not a dot. That's an open hole. Okay? So that's not f times g. If it were a dot, it'd be f times g. That's f composed with g at x. Now, what does that mean? It means this. It means f at g at x. Now, I want you to notice something. Look at the order. F is on the left first. F's on the left first. G comes next. G is next. But the reason you need to write it like this you're used to what we call nested groupings, like parentheses inside of other parentheses. You always go from the inside out, not the outside in. So if they tell you to do F composed with G at 2, you need to write it like this. See, F is first, G is second. But what do? Remember, I go from the outside in. So I'm going to put 2 into G. And then that answer is going to go into F. Because in the real world, you have compositions of functions a lot of times. Like, think about it. If you work for Nissan, you're not going to build the whole car by yourself at the plant. It may be that your job is to put the front doors on. And then the next person puts the back doors on. So the car comes to you and you do your job. What you end with is what the next person starts with. That's what composition of functions does. See, the 2 is going to, I kind of do it pictorially. I'm going to show you how to do it with pictures and then how to do it without the pictures. And you can do it either way you want to, whatever makes more sense to you. Pictures usually help people to start with. So I go from inside out. So this says to put the 2 in G first. So I took my 2 and I put it in my G. See, it's going into the G function. So what's going to happen? That 2 is going to go in place of that X. So like over here, what happened? That meant I put a 2 there and squared it, and then minus a 2 and then plus a 4. When you do that, the answer is 6. So when you put 2 in the G function, 6 falls out. But what happens when it falls out of here? It falls into there. See, what G ends with is what F starts with. So 6 is going to fall in for X. So I'm going to take that X out and put 6 in. And when I do, I can get 23. So the final answer that comes out of the whole thing is 23. So see, notice what I did. I put 2 in G, and this answer came out to be 6. So 6 got put in place of this G of 2, and then 6 went into F, and then the final answer that came out is 23, and they're going to want the final answer. Now, instead of doing F composed with G at 2, what if you did G composed with F of 2? Now, remember, you need to write it like this. Remember, G comes first when you write it. F comes second. G at F at 2. But see, you go from inside out. So this time, 2 goes into F first. So I listed the F function first. So 2 goes into F. So what's it going to do? It's going to take that 2 and triple it, and it's going to add 5. So if you take your 2 and you multiply by 3 and you add 5, you get 11. So 11 is going to fall out. Well, F of 2 is 11. What's that 11 going to do? It's going to fall into your G function. And they're going to square that 11 and then subtract 11 and then add 4. So when you do, you get 114. So the final answer is 114. So make sure you follow order of operations, parentheses inside of parentheses, parentheses inside of brackets. You work inside out. So the 2 goes in G, and then that answer goes in F. Up here, the 2 goes in F first, and that answer goes into G. So that's how you do it if you want to draw pictures. And some people really like the pictures. All right. Now I'm going to work one with picture and one without a picture. Okay. Same problem. But this time I'm going to do F composed with G at 1 with the picture. Now, first, write it this way. Remember, F is first on the left, G comes next, but I put the 1 into G first. So that's why I drew this one and put G in there, because I knew the 1 was supposed to go in G first. So a 1 goes into G. So those X's get replaced with 1s. And when you do that, 4 is going to fall out. Well, where's 4 going? Well, 4 is going into the F function. So that X gets replaced with a 4 and 17 falls out. So this final answer would be 17. Now, what if you did it without the picture? I'm going to put 1 into G. So I went up here. That was my G function, and I put a 1 into G. So I squared it, subtracted it, and added 4, and 4 came out. So I would replace this G of 1 with a 4. Now, where's the 4 going to go? It's going to go into the F function in place of X. So I went to my F function, 3X plus 5, and I replaced that X with a 4. And 17 came out. So my final answer is 17 when I do it algebraically, and my final answer is 17 if I do it pictorially. So it's whichever one makes more sense to you. So what if this is a different function? F of X is 2X cubed plus 1, and G of X is 4 minus X. And I said do F compose with G at 3. F at G at 3. So that says take a 3 and plug it in G. So I go up here to G and I plug a 3 in for X. 4 minus 3 is 1. So G at 3 is 1. So a 1 would fall out. And where's that 1 going to fall? It's going to fall into my F function. So now I go up here to F and I replace that X with a 1. If I do that, 3 comes out. So my final answer is 3. But if you want to draw it, I'm going to put the G function first, and 3 is going to go into G, and 1 is going to come out of that G box, and 1's going to go into the F box. So I don't care if you do them algebraically or you do them pictorially. What about G composed with F of 2? Well, see, I work inside out, so negative 2 is going to go in F. So I'm going to put negative 2 in F in place of that X. So that's what I did. All right. That negative 2 gets cubed, and a negative 2 times a negative 2 times a negative 2 is a negative 8. So when you say 2 times a negative 8, you're going to get a negative 16. And when you add 1, you get a negative 15. So if you put negative 2 in F, negative 15 falls out. So that's why that's a negative 15, because F of negative 2 is a negative 15. And that negative 15 is going to go into G now. So on G, in place of that X, I'm going to put a negative 15. Okay? So I've got 4 minus a negative 15. Well, minus a negative is plus a positive, and 4 plus 15 is my final answer will be 19. So I don't care if you do them picture-wise. Like if you like drawing them instead, just make sure that the innermost one is the one that comes first. The innermost one is the one you write down first if you're drawing a picture. So you can do them pictorially or you can do them algebraically. Okay? So for homework, that's what you're going to be doing. They're going to give you 2 different functions, and you're going to add them, subtract them, multiply them, divide them, and do compositions. Now, when you're adding and multiplying, the order won't matter. But when you're dividing and subtracting and doing compositions, the order will matter. All right? So just be careful. Make sure you pay attention to the order. If you have any trouble, just email me, and you can snap a picture of your work, and I'll see if I can find your mistake and send it back. But, you should be able to check your answers in the back. All right? So y'all stay safe. If you need me, let me know, and I will see you next week.